So I had to build a special index for a elevator, which with lights, nothing out of the so I had to build a special plus string
on the around the dot. Hello everyone, welcome to tonight's meetup. I'm Thomas Pan. I'm working eBay in search backend. I have been with the company for more than 7 years now, and I'm the organizer of the meetup. And in case, so we're still finding all the speakers. In case you know someone you want to recommend or you want to volunteer to speak, just let me know. So we will see how things can pan out down the road. Before we start the meetup, normally we welcome anybody in the audience to make any announcement. Anyone? Raise a hand. Okay.
My name is Stefan Gower. I have a website up for topicscout.com. We've got some cards here. It's very unusual. It is a classification site that is working with large topic trees of over 10,000 topics. It's actually classifying these up to precision levels are 80%, over 100,000 web pages. And all the topics are generated automatically, no human editing, and the cost of creating a topic is almost trivial. So take a look at the data there on the website. There's some pretty interesting lexicons there. There's thousands of examples.
Thank you. Any more announcement?
Thomas, you have to turn the music down. I don't know where it's coming from.
I don't know either. Okay, let's finish that and then I work on the music part. Any more announcement other than the music part? All right, so let me quickly introduce tonight's speaker. We actually call the person, the name is a little bit loud, but we call him JD, who is a research manager in the Geo team in eBay. And tonight's topic is about machine translation. Okay, without further ado, I just hand over to JD. Thank you. I will
start with music. All right, so as Thomas said, I'm going to present what we are doing at eBay in their area of machine translation for enabling cross-border trading. All right, and there'll be mainly three parts to my talk. One is motivating why eBay went into machine translation about a year and a half ago, and what specific or what difficult about what's specific about machine translation at eBay. Then I'll talk a little bit about the team type patterns. All right, so motivation. As you know, the world is not optimized for cross-border trading, as not everybody speaks the same language. And as you can see, a lot of Russian, a lot of Spanish, Chinese, and of course English is spoken around the world. And if you join this data with the expectation in terms of e-commerce growth, you clearly see that there's a huge opportunity in terms of commerce in Spanish-speaking countries and Russian-speaking countries. And that's mainly the motivation why we went into machine translation. It's really to accelerate cross-border trading and allows people from around the world to connect with buyers and sellers on eBay from anywhere and buy their goods and trade. And actually, so we, as I said, we started machine translation about a year and a half ago, and we launched machine translation for Russian, Latin America, meaning covering Brazilian and Spanish, and more recently in Europe to facilitate intra-Europe cross-border trading. And of course, we will tackle more languages in the coming months. All right, so let's look into how we do machine translation at eBay. But let's start by what we translate. So on eBay, we have on the eBay website, we have two types of contents. We have static pages, meaning menus, navigation bars, and specific content, which is fairly static, meaning it doesn't change every day. We have experts writing this content, maintaining it, and there we can use translation expert, language to translate it. But we also have dynamic content, meaning all the goods that people are listing and selling every day on eBay. So we have about 30 million items listed every day on eBay. I think we have close to 800 million items available to the US buyer at any point in time, so that's a lot of content. And actually, if we want to translate that content, we need to resort to automatic techniques. So let's do the math and see what it would take to humans to translate. So, for instance, last year we had about 60 million US items eligible for cross-border trading into Russia for commerce in Russia. And let's assume that the listing, meaning the title of the good that the seller is listing, along with the description, which is usually at eBay some natural language, free-form text, is about 3,000 characters. And that we have a sentence duplication about 50%, meaning half of the sentences don't need to be translated because they are redundant. And let's assume we have a huge army of 1,000 translators. So to translate that much inventory, it will take 5 years. So clearly, it's not scalable, right? We cannot translate the eBay inventory manually using language spec, and that's why we need to resort to machine translation automatic techniques. So what's the translation flow? How do we use machine translation? So let's say I'm a French buyer sitting in France. In France, I want to buy sunglasses. So the first thing I do is I issue my query in French. Here we have this way on, which is men's sunglasses. And I press search, right, which is recherche in French. And what we do, if we want to enable, or we want to expose to the seller the US inventory, meaning the sunglasses that are listed by US sellers on the US side, we first need to translate that query, right? So, lunettes de soleil homme here will be translated to men's sunglasses. So the first call to the machine translation system. Then we need to run a query against the US search engine, right? In other words, we need to retrieve all the US sunglasses in order to be able to show them to the user in France. But these, of course, sunglasses are in English, so we need to translate them. So we need to call such the machine translation engine again and take all the sunglasses here, which are in English, title and the description. Here we're showing only the title of the goods. We need to translate that then to French. And then when it's translated, we need to show it to the user. But the point here is that the user experience for this French buyer should be as good as it is for a US buyer issuing a query against the US search engine in the US, right? It should be super fast. It should be so the user should not have to wait to translate. So one of the challenges is that translation should be extremely fast. So how do we do that? So we restart on statistical machine translation, which has started about 20 years ago, but is considered now almost competitive with human translation. And the idea behind machine translation or statistical machine translation is to train the computer to be able to translate from one language to another. And we do that by just feeding the system with a large amount of translated data, let it learn the statistical regularity between the two sets of documents in fair translation, right? And that's what we're doing. And then when we have a model, translation is just about sending a source sentence to this model, checking the statistics, and trying to find the most likely translation for the given sentence. So if you have any questions, feel free to interrupt us, please.
Is there a number of n-grams you're using? I'm thinking of languages where you have adjective first versus adjective last. you could get some long strings, and if you don't have enough n-grams, you'll never match.
Well, so in machine translation, we're talking about the length of the phrase. And your question is, do we limit the length of the phrase? Yes, for efficiency reasons. But we found that in the case of eBay title, a fairly limited, like 5 to 6 words in the phrase, cover most of the need in terms of translation of titles. These are titles, again, are short sentences that the user are putting as titles that attempt to describe what they say. When we go to translation, it's a little more complex and we need to resort to longer phrases. So we'll consider that. Okay, so I said we feed the engine with training data. So what do we mean by training data? These are what we call machine translation parallel data, right? Which are documents with their translation. And this data is produced by human translators, so that the translation is of high quality. So here as an example, it's a hiking guide, I think, in German, with its translation in French. That's typically the kind of data we feed to the machine translation. We're actually using two forms of data. So we're using static data that are available on the web. There are a lot of resources, and but they're not for e-commerce. So you can find easily European Parliament translated data. You can find medical documents. You can find technical documentations translated. But you find little e-commerce specific data, meaning translation of products and description of products and product material and things like that. We also feed the system with monolingual documents, meaning documents in the target language. So here, if we're translating from German or trying to train an engine to translate from German to French, we would also feed the system with a large amount of French documents. The reason is that we want to teach the system to be fluent. And basically, what that means for the model is to be able to measure how likely the given sentence is in the target language. For instance, in English, bag red is much less likely than red bag, because adjectives usually go before the noun. And that's a kind of knowledge you can acquire from monolingual data. So we feed monolingual data to be able to teach the system fluency. So what is the translation model for a machine translation engine? It's two things. It's a phrase table, and phrase table is simply put phrase pairs or sentence pairs. One is the source language, the other one is the target language. So here, this is a phrase table for Portuguese to English. And so for the first example, we have the Portuguese phrase 2 or 3 phrases. So I don't speak Portuguese, so I don't say it right, but and then its translation 2 or 3 sentences. And then the numbers behind that are probabilities and statistics used when we're making translation decisions. And also, as I said, we also the model is also contains also a model for fluency, which is basically all the sentences observed in the monolingual training data with their value. So I think here it's not negative probabilities, but basically it's the likelihood of each of the sentences. So this was one of the earlier model we trained, and this one was trained on 8.6 million sentence pairs, containing roughly 93 million words. And the fluency model was trained of 150 million sentences containing about 1 billion words. And
Question?
sure.
So do you just look at translations which are, just pairwise the same, or do you generalize patterns that you see that repeat
Well,
sentences?
that's a purpose of statistical machine translation. So with the amount of data, the system is trying to learn statistical correlation between sentences and sub-sentences that we call phrases. So hopefully the system is learning patterns. So actually that's a goal. Okay, so and on this data, the phrase table has 30 million phrase pairs, and the fancy model about 500 million phrases. Okay, so I said, so we're feeding the system with what we call parallel data, right? Documents and their translation into target information. But I didn't say we tell the system at any point what word is translated into what was the target information, right? So there's no, we don't provide the system with what we call alignment. So we just feed the system with sentences, and the system has to discover what word corresponds to what word in the translation. And if you look at that example of sentences, sometimes it's very tricky. So let's say the debate is closed. Example in the alignment with the French sentence, the debate loop, fairly straightforward. Each word in the French sentence aligns with only one word in the target language. And then if you take another example, would you accept that principle? Things are getting a little more complex because there's reordering, right? The verb and the pronoun are not in the same order in French and English. And if you take even more complex sentence, it becomes very messy, right? The alignment is all over the place, there's a lot of reordering happening, and there are even some words that are not aligned. Like in the French day, the article doesn't have any equivalent in English in that sentence. So it's fairly tricky problem. So how do we solve that? Well, that's using unsupervised word alignment based on the EM algorithm. It's a fairly standard algorithm that was proposed by IBM like 15 years ago. And the idea is actually fairly simple, fairly intuitive. So the goal is to learn translation probabilities, right? We want to know what phrase, what word translates to what word. If we add the alignment, if we knew for every sentence pair in the training data what word was translating into what, computing this phrase table would be easy. We would just have to count how many times this word is aligned with that one, and that would give us a probability of this word being translated into that other word. But conversely, if we had the translation probability, we could also compute the alignment, right? We put the most likely, we'll align each word with its most likely translation. And that's exactly what the algorithm is doing. Starting with a random alignment, computing the translation probabilities, and then reiterating that process. And it actually does converge to the right alignment. So I won't go into the mathematical detail, but the idea is as I was just described, iterative process. Yes?
You had, basically you're talking about doing word alignment, but on the example you had on the slide before, I assume since it was would, you were doing a subjunctive question. Would you do, was that represented by the French ending? And in which case there are auxiliary words that come and go between languages?
So, so there are models, so we're using models of
modal is what I was saying rather than model.
To decompose the language. So yes, you can perform the alignment on suffixes and prefixes. We don't do that for English, but for other languages, in particular German, which are agglutinative language, where there's a lot of compound that you need to split, that's necessary.
So you can add and subtract words as needed. You go between languages.
So in the case of English and French, actually, it's not really necessary. You don't need to split the words. You don't need to understand the suffixes and affixes of words. Or maybe I didn't see the question actually. Maybe you're asking whether or not we ignore some words and aligning the
Well, you're talking about word alignment here, but things like modals would do those auxiliary words. You have to assert them in English, and you don't do them apparently in French, and that's just the tip of the iceberg potentially.
Yes, as I said in the last example, not every word needs to be aligned. So the model is able to skip words and ignore some in any language, in target language or source language. Sorry, I thought you were talking about suffixes and conjugate. All right, so as I said, the model consists of a phrase table and a fluency table. So how do we use it? Well, translation time. Well, let's assume we have a Portuguese sentence we want to translate. In that case, frases de música de los hermanos. What we need to do is to look into the phrase table for every word, diagram, trigram, almost all the sentences, all the phrases that you can generate from that sentence, and find which phrase translates into which, and compute the most likely sentence. So what needs to be done is actually serve the space of all translation given the translation priority we have in the phrase table. So here is what we call the prune tree of the search space. So actually the real search space is much larger than that, even for a sentence like that. It's about 20,000 hypotheses, but you can do fairly standard pruning by limiting the skipping of words, for instance. You may say, okay, I don't want to skip more than 3 words in my hypothesis, right? So by doing this kind of heuristic pruning, you can reduce the search space and the number of hypotheses to consider into a few seconds. But still, at translation time, you have to compute the priority of all these hypotheses in order to find the most likely translation for the sentence. But we can do that fairly efficiently, as I'll show later in the presentation. So actually, I'm not going to give any more detail of machine translation in itself. I'm going to switch focus now on why it's difficult at eBay and what's specific about translating the eBay inventory. As I said, if you want to know more, there's ample of literature around machine translation, and we can learn much more than what I just said. Sure.
Before we move into why it's difficult for eBay, so how do you measure the quality of these?
I'll talk about that.
Okay, you're coming to that.
Yes.
Okay.
So, a question regarding the way that you are doing machine translation. I'm not expert in NLP, but I remember when I have used some library like a sample core NLP. I know that there are methods that create like parse the sentence and create a tree, right, from that. My understanding is that if we have trees, it gives us some pattern, right? And probably translating from a generalized pattern is a bit easier. So my question is why you have chosen this mechanism rather than.
So there's been a lot of work around trying to use dependency parsing as a feature in machine translation, name entity recognition, and unfortunately, although you gain a little bit from that, it hasn't shown to be increasing dramatically the accuracy. What's more promising now is what they call using semantic with machine translation. There's a lot of research into combining knowledge about the language and statistical approaches. So if you go back to this machine translation, until the 80s, it was mainly based on linguistic rules, manually crafted for the most part. And then with machine translation, people from the academia shift totally to purely statistical techniques without any language-specific domain. So now there's a tendency to group these two and try to get the benefits of both worlds. So using dependency parsing and linear kind of this approach. But again, people are now looking into leveraging semantic parsing for machine translation. Okay, machine translation at eBay. So as I said in the beginning, right, when we have this French barrier issuing a query and potentially purchasing US inventory, we need to be very fast. And actually, our machine translation engine is very fast. So in terms of search, we have very strict SLA, so the response time of the engine does not exceed 20 milliseconds in terms of translation. So when someone issues a query, we must respond to that query within 20 milliseconds. We must translate that query within 20 milliseconds. The reason is that, remember, after we've done the translation, there are other things to do, right? We need to search, we need to call the US search engine, then we need to translate back the inventory, and eventually gives a result. And actually, 95% of our queries are served under 40 milliseconds, or around 40 milliseconds. So machine translation can be very fast, and it is like and this is achieved through optimizing the algorithm, but also leveraging servers and an efficient infrastructure to support machine translation. Another aspect of eBay which is important to take into account is the scale of things. Right? As I said, we have at any point in time almost 1 billion items available for purchase on the US website. And that means that, for instance, we're selling a pair of shoes every 2 seconds, women's customer every 2 seconds, headphone every 12 seconds. We sell a car every 2 minutes on eBay, even a boat every 35 minutes. So not only we have a large inventory, but also we have a lot of queries coming. So that's another reason that we have to be extremely fast in terms of in-depth machine translation. And also the diversity. So think about traditional translation agency, right? They would get a project, for instance, maybe in the medical domain, and we spend effort to translate that. But that is our focus on one domain. At eBay, the story is much more complex because we have all sorts of items, right? We're selling consumer electronics, power tools, sporting goods, even pets or clothes for pets, perfume, and sometimes we sell $1 million bags, right? So in that case, we have to make sure that translation is good quality. So this is another challenge of the translation task, is that we have a lot of diversity, and then we need to reflect that diversity in our training in order to be efficient at machine translation. Yeah, we have around 15,000 leaf categories of different categories on the eBay website. So again, a lot of diversity.
You didn't decide to solve this issue by just scaling up, say, doing 20 languages and translating everything into 20 languages offline. So then you would already have them translated.
Well, we cannot translate queries offline. We don't know what our user.
Well, the query is in a native language, but all the descriptions being could be done beforehand.
So actually, we do cache translation. So so offline, well, we have again like 30 million items listed every day. So still, we need to translate this 30 million items, or at least the ones that are requested by the user. Right? So when a user issues a query and we serve an item, we translate these items, also cache and translation. So we don't redo it again and again.
You wait until a query comes in before, as opposed to you get a description, you translate it into all the languages, and then whatever language a query comes in, it just goes against what's already translated. Then you have no speed problem.
Still for the queries, and also again, 30 million items to translate every day within 24 hours. So it's not so much as
you just have but your machines can take, if they need 10 minutes to do it, they can do it. Just buy more machines.
Yes, the whole trade between cost and efficiency. In terms of search, also. Yes, please.
I'm just curious in which case you need to translate the query. For example, if I type a query in Chinese, most likely I'm interested in my product from China or product in Chinese. So in that case, most likely we do not need the translation, right?
So when you issue a query in Chinese, we need to translate it because we want
Chinese product. Most likely I'm interested in Chinese product rather than in product which is like American product, which can be like a match after translation. That's probably not what I'm looking for, right?
Not necessarily. I mean, remember, our goal is cross-border trading. We want to show to Chinese buyers goods that are sold in the US and that maybe they don't have access to each other. So in that case, we may translate we will want to translate the query. So that will show US inventory.
My argument is if a person is searching in a native language, most likely interested in the product from that native country or something like that.
So users have the possibility to explicitly say what they want to see. So they can, click check a box on the website and say, I want to see only local Chinese inventory, or I want to see US inventory, or I want to see worldwide inventory. So that's how much is it. And actually we observe that when people, so actually people don't have necessarily the knowledge of showing US inventory, they just want to buy something. I'm a Chinese seller, I want to buy it on eBay. I don't care if it's coming from, I don't even know that we're showing US goods from So if you might in Chinese, and just, it's transparent for me, I don't know.
So you translate everything into Chinese, like for example, if I have a file in Chinese, there's a product which is completely in English, you translate everything into Chinese, including the product description and the product title, everything.
So actually, I'm going to touch a little bit about that. So
People do it. I mean, the reason this project was done is a lot of Russians come to the eBay.com site and shop and buy things. Not kitchen tables, but a lot of Rolexes.
yeah, so that's right, it's a very good point. So cross-border trading started even before we enabled machine translation. Right? So even before we had machine translation, you would see Russian queries coming to the US inventory. But then we return no results because the inventory was in the US, was in English. So that shows that yes, there's a need for translating the foreign queries into US.
So we have some listings which are in foreign language, which is why some of the queries are sent in both languages, but the majority of the cases are not in the foreign language. They need to be translated that way so that they are accessible.
A lot of companies don't do cross-border trade, but eBay does a significant business in cross-border trade. I just bought ski boots from Canada, which didn't need to be translated.
So actually, as I said, we are selling foreign queries, meaning when we from the queries from Russia, we see a lot of Russian queries, but we also see English, and sometimes it's difficult because we should not try to translate queries in English, right? So we need to be able to identify the user language. So for Russian, that's very easy because it's Cyrillic, it's a different alphabet. But think about people issuing queries from Portugal, right? Or for Brazil. So if they type TEAM, they may mean something in Portuguese which is not the word team in English, or something from France. Someone types figure. So figure in French means face, it's not a number. So we need to understand when to translate and when not to translate. But sometimes that's tricky. And we also see a lot of queries. For instance, here we took a sample of 10 million queries, and we identified like about 300 likely misspelling of the word something. So not only we need to be able to translate all sorts of queries, all sorts of languages, but also we need to understand that sometimes there is misspelling in the original language, in English, so it's a very wide range of what we do. But even more than that, there are keyboard layout issues. So in some languages, Cyrillic, Korean, Arabic, so they use a different layout, a different keyboard. But still people sometimes want to type English, so that they need to switch from one language to another, from one keyboard layout to another. And what we observe is that quite often people forget what layout they are in. So their keyboard is in the Cyrillic alphabet, but they think it's in English, and they start typing an English word with the Cyrillic keyboard. And that results, for instance, in that weird Russian word, which is not actually a valid word, but it's a keyword iPad typed with a Russian layer. And so in that case, we need to identify that there may be a keyboard mapping issue, and we need to decode the characters to English to recover the word, translate it, and then start to write eventually. But again, there are use cases. For instance, this Russian word here looks like a B and A. It's a valid brand, I believe, in Russia, but if you decode it using the keyboard layout, it's also a valid acronym in consumer electronics. It's DFP, meaning digital flat panel. So again, a lot of contributors need to take care of. Even worse, so what we have observed to our surprise is that sometimes people switch keyboard in the middle of the word. So they are, for instance, using the Cyrillic alphabet in the Cyrillic layout, and start to use the Cyrillic letters that look like English letters to type case in that case. So the Cyrillic C, there's a letter in Cyrillic that looks like a C, so they use that to start typing case. Same thing for A, and then when they're about to type the S, they realize that it's the wrong layout, so they switch the layout, and they switch to English and finish case by typing S. But actually, for the computer, it's a strange entity that is coming because it's half Cyrillic with a specific UTF encoding and half English. So again, we need to take care of that case and decode the word by translating. Actually, we had a paper at EMMOT last year. So if you're interested to learn how doing that, you can find out. Another issue that we have is that we should not translate everything, right? If someone is typing Apple, we should probably not translate it to the fruit meaning of the word, because we don't want our iPhone inventory looks like Russia shopping in Russia. Same thing for like clothing. There's a lot of clothing brands that contain valid English word, and if you don't pay attention to that, you will translate. So Hugo Boss, we should not translate into the boss, right? Hugo. Clothing like Gap, with another example, Coach, Free People. There's a lot of clothing brands that are actually English words that we have to not translate. And it's not specific to English, of course, any language. Petit Bateau is a French brand, which if translated literally means a small boat, but we should not translate that. We should preserve understand that when the user types Apple or Hugo Boss or Petit Bateau, it really means the brand. All right, translation quality. So back to your question. So we have several ways to measure translation quality. We have automatic techniques or automatic metrics that we use before we launch on the site the translation for the machine or translation model, and that we use to tune and measure the performance of the model. And these are fairly standard techniques. We have heard about the BLEU score, which is basically using human translated sentence as gold standard to compare or to measure the quality of the translation produced by the engine. And basically it's looking at the kind of overlap in terms of n-grams in the translation and the gold standard. But you also have other techniques like word independent error, position independent error rate, based on edit distance that allows or not to movement of block of words, just single words. So there's a few techniques we use for measuring the quality and actually optimizing our models. But we also use human judgment because the BLEU score is not always very accurate, and other metrics are not always very accurate. So anytime we launch a model, we have a fairly constrained QA process where we ask linguists to actually rate the quality of our translation. And we use several ways to do that. For queries, we actually run the translation against the search engine, and we ask the linguist to determine or to assess if the search results are actually meaningful for the query. And we also, of course, ask the linguist to rate the quality of the translation itself in terms of fluency, adequacy, and correctness in the target language. And then, of course, we have A/B testing, fairly standard in the industry, right? Once we are at the point where we can launch a model because it passes the automatic and human language evaluation, then we enable it to fraction of our users and measure the impact of the translation using several behavioral metrics. But we're not done. Even if something passed an A/B test, we still do a lot of analytics to constantly monitor how we're doing in terms of translation. We look at we're basically using activity level, looking at how our users interact with the site to assess the quality of our translations. Yes.
So I have a silly example. I'm sure your translation would not do this, but just for the sake of example, say if someone was purchasing something like a yellow dress, and they had an image of a yellow dress, and it's translated over. Instead, it's in French instead of being shown. It's they put it noir, and obviously it shouldn't be noir. Is there any way for a user to react in some way that you can infer that there was an incorrect translation and get feedback from it?
Well, there's two answers to the question. First, there are implicit metrics, so we can look at how user behaves. Right? If some people never click on our translation or never buy the good, that's maybe an indication that we are getting it right. And also there's explicit feedback, so people can leave comments and give feedback, explicit feedback for translation, and that's another way we can get information about the quality of our translation. Yes, so we're looking at, once we have enabled translation, analytics like the query volume, like do we see an increase in the number of queries, do we see a drop, number of unique visitors, engagement, like how long people stay on the site, number of null results for our queries. So usually anytime we launch translation, we should see a huge dip in the number of queries returning null results, right? Because all the queries that are in the foreign language that we did not answer properly before we enable translation are now treated correctly in the return results. So we should see a drop in number of null results, queries not returning. So that's some of the metrics we're using. As I said, people can leave explicit feedback, and so this is feedback we got from Mexican users about our Spanish translation and for Russian users. So, and it's actually very encouraging and very valuable. So people are very enthusiastic about machine translation for e-commerce. So here's the code. Everything is in Spanish, very important for that user. And people can buy even if they don't understand English. We found that 68% of our Russian users said that translation improves their shopping experience. 80% found the translation of the quality to be very good. Like here under the code, much clearer way to understand what exactly is sold. I like this one. Any machine translation better than confusion, and everything got clear now. We also completed a survey to explicitly ask people if they feel that machine translation is of quality and helping their shopping experience. Actually, even for even for highly fluent people or people that created themselves as highly fluent in English, even in that category, we had more than 30% of the users saying that the translation improved their saving experience, and quite a lot of people say actually that the translation is of the highest quality out of a scale of bad quality, medium quality, good quality, and highest quality. So it's very encouraging.
There's a money-back guarantee with eBay. Do you ever get that exercise because the thing was translated wrong?
So I think we have a disclaimer saying we show the translation, but user can mouse over the translation. This is the original.
They have no knowledge of the language. They depend They're relying on eBay to do a correct translation, and if you don't,
yeah. So there's a generally they think that machine translation is not perfect, and we may get it wrong in some cases, and in that case, I mean, machine translation is to help the machine. You know, you can guarantee it's always going to be perfect. So,
you cannot guarantee it.
you can.
Uh,
Yeah, I mean, machine translation is very hard, and
Yeah, well, the user walking up to eBay doesn't know that this is machine translation. They know it's translated, and eBay is putting its reputation behind the translation that it's correct. If you get it wrong, and you sell the black dress for the yellow dress, they're going to want their money back.
yeah, that's right, that's right. But so legally we're not able for the quality of translation. Again, machine translation is a very hard exercise, right? And I mean, even try Bing and Google, you see that they do. They don't do always do a great job at translation. So it's a very hard problem. So we can take the risk of like claiming that translation is always going to be perfect. Right? So we're providing that as a service to help the user.
So people can't exercise that option to say the translation was wrong.
They can give feedback, and we're going to improve. Actually, we're constantly using that feedback to improve our engine. So hopefully we'll
Continue the yellow and black dress example. So if I bought the dress and thought it's the wrong color for the translation, would I be able to return it anyway, or is it just fait accompli? I have to keep the dress as is now?
No. So that's a different. No, most of the users allow returns. So in most cases you can return. Also remember that there's an image with the item, so it's not only the translation. So you have all the data to ensure that.
It's a little bad example because of the color, but maybe other examples probably the image wouldn't help you so much.
Like the cover of a couch or the couch itself. So if you just want to buy a couch, you by mistake bought a cover of the couch, just the couch cover.
Yeah, that can happen. And yes, we're aware of that, and we're trying to do our best to make sure that this kind of bad experience don't occur.
Could you return the item under all circumstances, or if it cross a certain price threshold, are you then stuck with the item?
So it really depends on what the seller offers. So again, we're just a marketplace, so we don't own the goods. So it's really the seller policy. So we're giving a lot of incentive for sellers to offer the best return policy, but we are at the end we're not the one deciding.
Understood. It is a very hard problem.
Yes, but we try to make sure that this is very explicit. So if you go to the eBay page, you see clearly whether or not the user accepts it. So when you buy something, you should know whether or not you're going to be able to.
So does that mean that all the production translation on eBay is done by machine and no human intervention?
Yes, for the dynamic context in all the items, yes, it's done by machine.
And do we have any statistics on how often those type of return or any negative feedback comes in with the machine translation?
We do, but we're much more interested in the positive feedback, which I just showed, which is like much more frequent than the negative feedback. So yes, of course, we have statistics.
So for these cases, basically translation motivated issues, the statistics do not differ much from within basically the context. And translation motivated issues are not they are not changing the statistics by much. They're not changing the statistics. So that means the customer using machine translation and the customer not using machine translation has the same feedback basically.
Okay, thank you.
Sometimes you might be blaming the seller.
Oh, that was so weird to know the error rate there.
All right, so
could you share the sample size of the people that were participating?
interviewed in that?
The people that responded positively, was there a sample size?
I don't have that on top of my mind. Do you remember?
I think for that example, it's a little bit more than 1,000 people for that sample.
Okay, so I'm going to conclude with a quote about the machine translation team. So it's a team composed of researchers. We also have, of course, engineers that are building all the infrastructure to make sure that we can self-translation very efficiently and very fast, as I said. And we also have, and it's very important, language specialists or linguists that are helping with producing training data. So as I said, we using data that is available on the internet, also producing our own training data, and linguists are helping with that. And also, as I said, helping with ensuring high quality in the helping in the process. One very important thing I didn't say is that our machine translation engine is built of an open source library which is called Moses here, and so we also contributing with improvement to that library which is open source by contributing back to the community. Yeah, so as I said, open source is very important for us. We're using Moses, and we want to make sure that all our learnings and findings are benefiting us in the community. We also try to keep a tight connection with academia and constantly engaging with researchers and to make sure we stay on the state of the art with machine translation. All right, that's it. Thanks for your. Any other question?
I have a question about search. So you said the search process is when the query is issued, you go through translation. Does that go through every single query that comes in, or does it only apply to, say, an entry site if it's coming from eBay in Russia, for example?
So we enable translation per geographic location. Right?
Oh, okay.
For instance, for Russia, so we would enable query translation for any query coming from Russia. But again, we have process to identify whether or not we should translate something. Like if it's in English, or if it's a query that could be valid in any language, something like that.
And also, if the query is issued in so some of the listings may be in the original, like in language that's harder than English, say for example Russian. And then when the query comes in, then you do a translation, search in the English listings. But then what do you do with the Russian listings?
We still show them.
So you still show them. So it's kind of search. So you issue the query using original language as well as translate language and combine the results.
Because as we pointed out, we have some actually Russian items or Russian listing on the US website.
Can you do a Russian demo for us live?
I could if I had prepared for that, but I didn't. Also, in the case of, for instance, Europe, so Russia, we started in Russia, there was no local inventory. Meaning we didn't have any Russian seller listing goods from Russia. So all we could do initially was to show the US inventory to Russia. But if you think about France and England, for instance, we have inventory in both, right? So when someone issues a query in French, we get both inventory and then blend it in the search result and show both. Eventually, users are not necessarily aware where the platform lies, where the inventory is going. And they click on it and then they can see it's located in France or it's located in England.
Do you give different weights to the matches in different language sets?
Yes. So there's a ranking process in correlation, translation statistics, and confidence in order to rank.
Thank you.
So
like, I'm just curious, do you all need to blindly read out? Because sometimes, for example, for acquiring foreign language, the recall from the listing in that original language might be big enough, so that maybe no need to do blind, right? So you can argue that the quality of the listing in the original language should be higher. The machine calculation is not always.
Yes, so we did a lot of user testing, and we have a very country-specific way to handle usability. So, for instance, in France, we may want to show more French items and limit English items to things that are not, supplied in France. In other countries, we may want to blend equally both kinds of supply. Very dependent on the country, but yes, we are looking carefully into that and to make sure that we serve the translated inventory in the best way for our users.
So would it make sense to translate it back to the original language and show it to the user and see if the user agrees that this is close enough to what they meant?
I mean, for everything
So English to French, and French back to English, and they're not going to be the same, but the user can decide if these are drastically different or.
So conceptually, yeah, it will be very useful to have some kind of user feedback of the translation. The problem when you do translation and back, that you lose quality. So your initial translation may be good, but then translating back, you're incorporating another level of noise.
True, but if blue becomes red, that's a huge thing, and the user may decide that this is not what I meant.
Yes, that'd be very useful. The thing that we don't want to involve too much our users at the cost of the user experience and the purchase process. The goal for them is to purchase, not to rate translation. So we have to be mindful about what we do. But maybe particularly with an opt-in, program that people could willingly contribute to helping us improve the translation rate.
So there may be certain relatively obscure kinds of items which may or may not translate into other languages in a direct fashion. I have a specific example. Maybe it does translate their language, but there's a kind of woman's hat called a bird cage hat, and sort of a veiled kind of thing, used popular in the 40s, but it's a real category under vintage hats that shows up. And I was trying to use that as an example, because when you get something like that, it's obscure enough even in English. I wonder even if it can be translated in any direct fashion into another language, and then of course the translation text might be small or non-existent. So do things, because it's a very hard problem we're dealing with, do things sometimes fall off at the edges when it just gets too hard?
Maybe. And I'm not even sure what would be the right behavior in that case, right? Should we still translate literally and let the user try to figure out? I don't know. That's a good question.
How does the translation quality differ among more similar languages, like Latin languages, versus like different languages like Chinese and English? Is it better or worse? The language is similar.
So yeah, there are differences between languages. Some languages are harder to translate. Now, at top of my mind, I don't have like accurate recollection of what is this. Do you remember, or do you have like?
We can say that some languages are more difficult than others. We know that, for example, Russian is more complicated to translate into English than French is. Depending on the language, the data which you can gather to learn from, even a harder language might end up not being as difficult. If you compare Italian to Spanish, the quality of machine translation might be just as good as Spanish to English, because Spanish to English we have much more data which we can learn from. So let's say we have 100 times more data to learn from for Spanish to English. Even though Italian and Spanish are much more similar, the quality of machine translation which we end up with is close. It's not much better, so to say. So there is more factors to it than just the closeness of the languages. There are more parameters. If you want, if we have a browser, I have a Russian username, so I can basically present that if you like. You want to try that?
Translate to Italian and Spanish, would you then necessarily potentially go from Italian to English, and English to Spanish?
So this is, some of the machine translation companies do that way. We decided we will go and do the actual translation from Italian to Spanish if you want to have basically Italian inventory visible in Spain. The reason for that is we assume that there is some accuracy which gets lost if you do the translation over English. And I can give you a very clear example. If you take Russian and German and you want to translate from German into Russian, there are certain features in these two languages which would get lost if you would translate through English. We're going to continue answering.
Are you passing the query and the listing through the same engine? Like, is the query translator and the listing translator going through the same pipeline? Is it the same engine? Okay.
It's different models because we don't train the engine the same way to train to translate queries and to translate longer titles or descriptions. Then it's basically the same title. It's the same pipeline, just calling it on a different mode.
Okay.
You might have a dedicated eBay Europe and eBay Asia separate sites, and then all merge it in one the query code. Does it go across, or you have something like a common gateway where we can?
For the search engine?
Yeah.
Yes, it's a common gateway.
Okay.
I kind of missed the first part of your talk. I just curious. Since other companies such as Google and Microsoft, they are also working on machine translation. So on the high level, what's the difference between your approach and their approach?
Well, we are translating specifically in training for e-commerce inventory. And actually, initially we tried with publicly commercially available translation engine, and we found the quality to be not always sufficient for e-commerce inventory. And a simple example is brands. So there's many brands for which Google Translate is getting the wrong, it's getting a translation. So it's tuning to tuning the engine to e-commerce.
So does that mean that you are just you apply machine translation to a specific vertical, but under the underlying technology, what are the difference between your approach and for example Google's approach?
Well, I'm not. I don't think anybody is very knowledgeable about Google translation or Google. So I'm not sure exactly what they're doing.
Sometimes they publish some very some kind of high level technique in academia papers, but it's not always the.
But what I can say is that it's similar techniques. It's also statistical machine translation. So the approaches are in a sense the same. And the difference is training data, the way we tune the model, and probably heuristics are using and we are using to make sure the translation is the best way. So this is the Russian site. That's what the Russian user sees if they go into eBay.com. I don't have a Russian keyboard. I couldn't type in any Russian query, but I will try to search for. So if I had typed it in Russian, it would give me the results back in Russian. And what JD was saying earlier is I see the original if I hover over it, and I can give it a rating. I don't know what the rating is for this, but it looks,
Is that the real-time translation when you moved over that line and translated, or is that already translated, just displayed now?
That is pre-translated.
Pre-translated.
And it's visible. So we do about 90 million queries, translate 90 million queries a day. We do pre-translation of about 120 million.
And what is the rest to 270 million? The rest is so with some titles are being translated on demand as well. So we don't do pre-translate every title, but some. So we do about 270 million translations a day between queries and titles.
For the price, do you apply the exchange rate on the price too? The price, did you apply the exchange rate on that? No.
Yes, it is. If you click on that, that is original price, and you see here the ruble price. Yeah, that is obviously not machine translated. That is.
Hassan, can you just grab a couple of those Russian words and then paste them in?
Oh, that's a good idea.
Not the whole thing.
You should remove that app.
Is that a good choice?
No, the app you should remove. Only the first.
Yes. Are we here on the on what network are we here? Okay. We can also do it the other way around, so we can just say, let's translate any English into Russian. Where is Russian? Do you see Russian? Okay. So find give me a query.
Snow chain.
Huh?
Snow chain.
Snow chain. We don't have snow here.
That is in Russia.
Oh, what does it translate to?
It should be snow chains, plural in English.
Is that it?
Yeah.
Well,
let's
assume it is.
I'm Russian.
Oh, very good. We should have chosen some other language.
We can look at the pictures though.
Do we have a question?
Yeah, we do have. No,
something was
some change.
So what was the difference here? What is this? Is that better?
Actually the previous one was better. This one is worse because basically what this one says is snow and then chain. Snow. That's all.
In English, starting it shouldn't be snow chain. If you want tires, chains on a tire, chain has to have an S on it. So it's not correct in English. You need to add an S before you translate.
If there's no open source technology, can these machine learning or these type of translation at this volume completed in the traditional technology?
Sorry?
If there's no big data, because you listed a bunch of open source big data projects, if there's none of those technologies,
Operator error.
Yeah.
Sorry. Yeah.
See, with a real Russian query.
Yeah.
You get something.
Yeah, that's wonderful. Very good.
So you can still see that.
I think that's probably because it's translated back to, like Russian, the two words snow and chain. So you get translated into English as snow chains, and then it's feeding to the search engine. Search actually the keyword matches snow and chains, and then you get translated back.
That's good.
What's an idiom? And you're not necessarily going to do well on an idiom.
Yeah, idioms are a challenge. I mean,
what if you tried snow chain as one word?
I mean that matched what we wanted, right? That matched what we wanted.
But that's not even clear what that should return in English.
Yeah.
Nothing. It doesn't translate. So let's. But I bet with you, if I put snow chain in here, it will give me a result. There's so many.
Yeah,
so many items on eBay.
Yeah. This will get.
Oh, there is something else. We do also some search optimization towards these kinds of issues. So we might be splitting it at the end of the day. I mean, Brian will be able to tell some of that.
Yeah, spelling errors or anything might
There's some magic on that end, independent of the translation.
Yeah, but still one point which is important to highlight is that our English we have to deal with is not always proper. And we see all sorts of misspelling and grammatical errors. Still, we should be able to resolve it.
Are you thinking about putting eBay public, making it public?
We don't know yet.
It might help people to help, if it's a translating service built for commerce, it might be more accurate than Google Translate, maybe.
For the commerce purpose.
Yeah.
Yeah, I mean, right now we are focusing on putting it in the workflows of eBay. What happens in the future, no one knows.
Okay.
So do you also have like English to Chinese translation?
I'm sorry?
Do you also have English to Chinese translation?
We're working on it.
So for the translation technology you develop, are you going to like open source some of the technology?
So Moses is open source. I mean, you can go into website online and download it. I mean, Moses itself is without the models. I mean, it doesn't have the models, so you have to have some scientists sit down, train the system, etc. That's what we started doing in 2013, mid of 2013. And initially, it's going to be challenging to build a robust system which can compete with the top MT systems out there. But if you focus on certain domain and have a lot of data, and we get a lot of data today, then yeah, I mean it's a good thing to do.
So do you plan to provide some kind of like a translation API so that like people from other e-commerce world can collaborate?
That's basically a similar question to, yeah. I mean, we don't know. I mean, nothing is impossible, but we have, right now we are focusing on our own workflows. So.
All right, thank you.
Okay, thank you.